Okay guys, this will be a brief video talking about the properties of liquids. We're going to talk about adhesive and cohesive forces, and we'll introduce the terms viscosity, surface tension, and capillary rise. Uh, Cohesive forces is a blanket term that refers to the interactions between identical molecules that keep them together in the liquid phase. And adhesive forces refers to the interactions between different substances, most commonly the liquid and its container, that tend to pull the liquid apart. And we'll see some examples of adhesive forces at work in a few slides. The balance between cohesive forces and adhesive forces, for example, will determine whether or not a liquid will wet a surface. And so we'll see some examples of that as we get through the graphics here. So we'll start with viscosity. As probably you already know, viscosity refers to a liquid's resistance to flow. The term applies to both liquids and gases. That is, it refers to all fluids. And so fluids like honey or motor oil, we think of being somewhat viscous in the sense that they pour rather slowly, whereas a liquid like water, compared to oil and honey, it has a lower viscosity. It's the cohesive forces, the forces that hold the liquid together, that give you a higher viscosity. Another property of liquids is something called the surface tension. This refers to the energy required to increase the surface area of a liquid. And I'll draw your attention to these pictures here. Okay, in the bulk liquid, a given molecule is going to be feeling attractive interactions in all directions. Okay, so there's sort of like no net attractive interaction in the sense that the liquid doesn't move. It does move, but it just doesn't move as much. And then compare that to a liquid at the surface of the interface between the water and the air. Here there is a attractive force towards the bulk, and there's no attractive force out into the air, and so this leads to a what we call the surface tension of the liquid, and it causes liquids to tend to minimize their surface area. So you see that the droplets that you see here, the reason they're spherical in shape is because the spherical shape reduces the surface area of the liquid droplet, and that tends to minimize the surface tension. Another illustration of cohesive and adhesive forces comes to us through this example of capillary action, which refers to the rise or fall of a liquid in a narrow tube, so a capillary tube. So these are very thin tubes. If you take glass and its open end and you place it into liquid water, what you're going to find is that the liquid is going to start to crawl up the capillary a little bit, and that's because there's a strong adhesive force between the water and the glass. We say that the water wets the glass. Contrast that with mercury and the glass capillary. In the case of mercury, you find that the liquid is depressed. That is, the capillary action causes the mercury to go down, and that's because the cohesive forces are stronger within mercury compared to mercury and glass. And it also affects the shape of the liquid-air interface in the capillary. In the case of water, you see that the meniscus that forms is concave up. That's because the water is attracted to the glass. Whereas in the case of the mercury, you see that it's concave down, and that's because the mercury is not as attracted to the glass as it is to itself, and that gives rise to the fall of the liquid mercury in the capillary tube. Well, as I said, this was going to be a short video. I just wanted to go through some of those definitions just so you've heard them once, and we're going to talk about phase transitions in the next video.